Hi, I'm Doug, K6JEY, and welcome to JEY Labs, where we have fun in the garage. You can see behind me is part of my bench and some of the instruments that I use. Today, we're going to talk about instruments you can use and what you might select for new or used equipment. So we'll start that with a screen share, and here we go. Test gear for hams. Modern choices on a budget, pretty much. So the most fundamental gear that we use is digital multimeters. You want to get one that measures quickly and zeros quickly, signal generator, GPS or 10 megahertz source of some kind, spectrum analyzer, and power meters, and some standards. So we'll go through that and some other things, and hopefully you'll find some things of interest. First of all, you might want to ask yourself, which gear do you use the most and whether it needs to be upgraded, which ones need to be upgraded, and what you might need in the future. You're thinking of expanding what you do, bands that you're on and so forth. And what kind of gear will you want to keep or get because it's your favorite, something you used when you worked in the industry and always wanted to have, that kind of thing. So that's some of the considerations, but if you write those down and think about it, that'll give you a list to work from when you go to the swap meet or you look on eBay. That should be helpful. So this talk is mostly about new equipment, best bang for the buck, absolutely. And it's listed from the most common gear to the oldest gear, least common. First is multimeters. I did this the other day just for fun. I scraped together a bunch of multimeters, mostly flukes, and tried to see how well they worked and whether they were still in calibration. And I used my 50 ohm handy calibration resistor, and this old fluke 6060A was still in calibration and read to 100th of an ohm. It's amazing. The rest of these all read 50 ohms as well. It shows that if you buy good instruments, it's worth it in the long run. Here's the two multimeters I suggest if you're in the mood to buy something that's really durable. A new one would be the Fluke 115, and an older one would be the Fluke 77. The 115 is a little bit smaller and easier for one-hand operation. It also has a true RMS AC voltage and current readings. The old 77 has been around for decades. You can drive over it with a car and it'll survive. And they're about $50 used each, get some good test leads. I've used mine since 1980 something, and it still works and it's still in calibration. Highly recommended. Here's one for the benchtop. It's again another Fluke in 8840A. A lot of these were military and a lot of them weren't. That doesn't necessarily mean that they're bad if they're military. Just try and get one in good shape. Some of them have been kicked around quite a bit. Get one that looks nice and it'll probably operate nice. They very rarely need fixing. They read, they're 5.5 digit meters, stay in calibration. They have 4 wire ohms readings and a null reading, a null compensation and things like that. They're a very good bench meter, maybe all you'd ever need. Here's something you do need if you don't have one, is a clamp-on ammeter. It's a DC AC ammeter. AC is easy to do, DC is a lot harder. This thing will read down to 1 milliamp DC amperes. It costs about 35 bucks. And it means that you can measure DC circuits without breaking the connection and putting an ammeter in series with it. You just clamp the meter on the lead and it gives you the current reading. At 35 bucks, if you're gonna do any kind of troubleshooting at all, this is really a no-brainer. Power meter. Well, I've talked about lots of different power meters, and this is the one that sticks with me. It's a Bird 4410A. Each slug is good for 7 ranges, and you probably only need 2 slugs. And they're not that expensive. And if you add up the cost of the meter and 2 slugs versus 14 slugs and a Bird 43, it's a no-brainer. But this one is 5% of reading accuracy, and the 43 is 5% of full scale. And they pull some tricks to keep the accuracy somewhat in line. But 5% of reading is a very good meter. And there are many more than 2 slugs. There are at least 12.5 slugs, depending on what range you want, so forth. But this is my recommendation for a watt meter. Frequency sources. Well, good old BG7 TBL has come out with quite a few things, and this is one of the good ones. I have, I think, 2 in my lab. Put a GPS antenna on it, and 10 megahertz comes out. You can monitor the digital stream if you want to, but basically, if the lights are right, the thing's working fine. Give it about a half an hour to warm up. GPS oscillators not only have to warm up the TCXO that's inside or the OCXO, but they have to average the GPS signal over about a half an hour. So I would say if you bought one of these fresh out of the box, I'd let it go for half a day or a full day before you did any serious measurement with it. Signal generators. I like this little guy. It's little. It has a serial input output. You can change the frequencies on the front to anything you like between 1.5 and 1296 megahertz. You can program these 2 buttons to anything. So let's say you're band spreading a 5-band shortwave receiver, and you're going from one end of the dial to the other. On a regular signal generator, you have to go back and forth and back and forth. This one, you can set the buttons to be whatever you like and go back and forth between the buttons and do the band spreading. It makes the job a lot easier. It also has calibrated level outputs of 1 microvolt, 50 microvolts, and minus 33 dBm and 0 dBm. It's not cheap, but it does the job of most of what you do for receiver alignment and maintenance. The only thing that's missing is something at 455 kilohertz for IF alignment, but that's fairly easy to come up with. If you want a more complicated and general purpose signal generator, I still have to recommend this, an 8642 A or B. They're listed as 100 kilohertz to 2 gigahertz, but they have an audio generator in here, down on this part, that comes out in this other connector between 0 and 100 kilohertz with a calibrated output and calibrated frequency. So in fact, using the 2 connections, you can go between 0 and 2 gigahertz. It has an extremely good attenuator. It's very stable. The thing is way over designed. It was an effort to recapture the market after the 8640 became old. And the only thing I'd say about them is that, like a lot of the older gear, as soon as you get it, replace the fan. This one is really simple. Take 2 screws out, pull out a little drawer, take out the old fan, put a new fan, plug it in, put the drawer back in and 2 screws. Because when the fans go out in these older pieces of gear, it burns up the power supply. I mean, it incinerates the power supply. So putting a new fan in after 30 years is probably a good idea, especially if they've been run a long time. These have been going for $500. They've increased in price, but I'm sure you can find one at a reasonable price. This is a basic piece of gear and worth spending some money on. Or you can go Chinese. BG7 TBL again, he has a 15 gigahertz signal generator and a 4 gigahertz one. Several of the models have little different variations. One of them has an attenuator, but I think you're going to be better off if you go with an external step attenuator of some kind. You're going to need to have enough attenuation to do 110 dB in the step attenuator. But look around on eBay. There's a lot of stuff, depending on the frequency range you want to work with, that may fill the bill. But an external attenuator is necessary. But you're going to spend, this is $168. Some of the models are a little cheaper. And then 50 to 75 bucks for an attenuator. You've got a small, easy to use, compact 12 volts signal generator to bring to the problem, rather than this guy where you have to bring the problem to the generator. So it depends on how you want to decide on your lab. This is not a bad idea. Okay, my favorite subject is spectrum analyzers. There are a whole fleet of these little guys out, and there's some new Chinese analyzers that have a lot of the same parameters. Almost all of them indicate frequency and amplitude really well. And in fact, that's what you want to use an analyzer for most of the time. But the inexpensive ones have a relatively wide filter in them, probably a crystal filter. that's 2.5 kilohertz wide. So the closest in you can get is 2.5 kilohertz. And I think the minimum scan width is about 100 kilohertz. Nevertheless, you see really well and well enough at $175. And it's portable. It's battery operated and portable. It goes to the problem rather than the problem to you. It also has an external USB program. You can hook up the cable, light up their free program, and you get a much better display that makes it and puts it in competition with some much more expensive analyzers. There's also a waterfall display. It really is much more than it seems as an analyzer compared to other things. Here's a trick I did last year for the microwave update. I put in a bias T and an LNB, a low noise converter with a WR75 input on it. And I turned my signal generator on about 3 feet away at 10 gigahertz, 10.368. And here's the signal on the analyzer. The LNB down converts the input to 618 megahertz, and the analyzer is tuned to 618 megahertz. So you have a battery operated, handheld, portable 10 gigahertz spectrum analyzer. Look at what Anritsu charges for those. $4,000-5,000 bucks. Okay, so yes, we'll move on. Probably the best bang for the buck on this type of spectrum analyzer is an Anritsu 8212B, MT8212B. These are cell site maintenance boxes. They generally come with lots of add-ons, like this one has a power meter. They have a antenna analyzer, cable default checker, and a VNA, a 2-port VNA. They don't usually they may take a 10 megahertz input, and this model has an RS-232 input and output. They're battery operated, the batteries are cheap, portable, they're generally in very good condition, and very versatile. For the money in getting a spectrum analyzer, it's probably the best bang for the buck. They're very durable. Some of the older analyzers, HP and Tektronix and so forth, if they go dead, you really have difficulty in finding anybody to repair them. Here's a close-up of the screen. You can see that the signal is again from the LNB at 10 gigahertz, converted down to 618 megahertz, and it shows the amplitude of the signal. Now that's at this particular scan width. This does not have the problem of close-in inspection. I think the resolution bandwidth is something like 10 hertz or 30 hertz. So you really get a full-featured spectrum analyzer with this, and all the usual indications around the display, several traces, 3 or 4 traces, and you can compare them. All the regular good tricks of a more expensive analyzer. The screen's a little small and it's a little bit old, but for the price and the functionality, this is by far the best deal. However, my favorite deal is the next model up. These are Anritsu 2712Es, 9 kilohertz to 3 gigahertz. They're a current production model. I don't know why they're so cheap. They work extremely well. They generally have a few accessories, but they don't do cable to analyzer stuff, and they don't do VNA stuff. It's really just an analyzer. But it does have a GPS receiver in it that will correct the master oscillator frequency, so that down at the bottom here, when it's operating, it'll say how accurate it is. It'll be parts per billion accuracy. The analyzer is basically SDR. So it checks itself every time you turn it on and calibrates itself every time you turn it on and calibrates the frequency every time you turn it on. But it's a really very sophisticated current production instrument with local area network, USB, all those kinds of interconnections and remote programs. And it's really quite a tour de force that's at a good price. Okay, I did the same thing with this. Let me move this little box. Did the same thing in a different band. I got a 24 gigahertz mixer. It goes from 18 to 26 gigahertz from an HP accessory mixer. Turned on my 24 gigahertz spectrum analyzer that was about 3 feet away. I tuned this RF Explorer signal generator. It's DC to 4 or 5 gigahertz. I tuned it to 4 gigahertz at 8 milliwatts. And I sent that into the LO port of the mixer and ran the output into the spectrum analyzer. So here's my signal generator 3 feet away at 24 gigahertz. So here's a handheld, battery operated, portable, 24 gigahertz spectrum analyzer for less than $2,000. Now you're missing a couple of things. There's no pre-selection in the front, and there's no attenuator. But at these frequencies, attenuators are easy to make. I've also used the same setup for 47 and 79 gigahertz with the external mixers and the same RF Explorer signal generator. Works very nicely and worth the trouble. And yes, it will work on the previous model. This setup at 24 gigahertz will work with this guy. So you're keeping your costs down and enlarging your capability. Oscilloscopes. Okay. You want one with auto set. I know you probably love your Tektronix dearly, but it may not have auto set. And you want one with 256 levels of intensity. A lot of the digital oscilloscopes have just a blue trace that goes across, and it's one. There's no intensity levels. Everything's the same intensity. When you get different levels, you get a more analog type display, like this guy. Here's a Rigol DS2102. And you can see the AM modulation waveform is very detailed. That makes a huge difference. And there's all kinds of other things. The math capabilities and the digital storage with the USB. You've got record and playback. These things are now about 5 or 6 years old, and they're about $500. This is the one I would recommend. It's just bang for the buck. It's about the best. Except for this. This is a 100 megahertz single channel oscilloscope, handheld, battery operated. It has a really nice display. This is how it really looks. It reads frequency and voltage. It has auto set, and it has memories for the displays. So you can go over and make a measurement, push memory, and then go back and analyze it. And you can dump it out the USB charging port to a program to annotate it. These are like less than $100. There's not a single 12AX7 in the thing. There's not even any 14-pin DIP ICs in it. And it works well. So this is the second. The DC ammeter and this are my biggest no-brainers. Okay, frequency counter. I'm not going to say too much except good old BG7 TVL has a couple of frequency counters that are good. And again, small, handheld, 12 volts. This reads 13 digits. It has an OCXO in it. You'll never read 13 digits accurately. Probably never read accurately, but it does have that. And it has some math functions of average and peak and that sort of thing. But for $115, 0 to 6 gigahertz, that's a pretty good counter. Miscellaneous. Yes, the LCR meter. Everybody needs an LCR meter. And when I get done telling you, you're probably going to get out your phone and start looking on eBay, and more power to you. This is a DE5000. It's a Chinese remake of a B&K $500 meter, and they're good. They're very good. Mine was only about 4 counts off of absolute, which is amazing. It has a 100th of an ohm resolution resistance, and it has ESR measurements, equivalent series resistance for capacitors. Now, most capacitors need to be checked at 10 kilohertz. Otherwise, you'll get an erroneous reading. So make sure this is set at 10 kilohertz. You get an ESR reading on the capacitor, and you get your little ESR chart out that says the value of the capacitor and the voltage and what the approximate ESR value is. ESR values are not real tight. If you get a box of, you get one of these meters, get a box of capacitors and go through it. The same values, and look at what their ESRs are. It's obvious which ones are bad. The other ones are off a little bit, and then there's one that's a clunker. Okay, that's the bad one. What it allows you to do, provided the circuit is discharged, is to do in-circuit capacity checking. You don't have to pull a capacitor out to see whether it's any good. You simply put the leads on it and it'll tell you whether it's any good. In-circuit capacitor checking. The 100th of an ohm resolution allows you to do short tracing. Let's say you have an instrument with a 5-volt rail in it and it's shorted out. Somebody shorted out. There's a shorted part someplace. So you put the minus lead on the ground and you go up and down the rail with the positive lead to where the least resistance is. That's where the short is. In circuit, you don't have to pull anything out except that screwy tantalum capacitor that went kablooey. Okay, I hope that's helpful. At $80 for that amount of help in your troubleshooting, it's a no-brainer, but make sure you get the leads with it. There's a bare meter that's cheap, but the meter with leads is worth it. They take a kind of funny little interface for the leads as well as the regular banana plugs. So that's helpful. Okay, nano VNA. Other people are going to talk about VNAs in much more detail. I want to just center on one particular aspect, and that's the load and double checking the load resistor for your VNA, whichever VNA you have. I took all of the SMA loads I have, I scraped together everything in the lab, up and down, sideways. And I made a list. And these on this side are all your regular teeny tiny SMA loads. And I thought I had one here. They're teeny tiny SMA loads. You probably know what I mean. Well, here it is. One of these guys. I'm sorry, one of these guys is an SMA load. Some of them look like this, some of them look like that. But they're basically 50 ohm resistors in an SMA connector. Well, I measured all of the guys and one of them was dead. It looked fine. It wasn't burned or anything. It just was dead. That one went out. The best one was 50.017 ohms. It was a Weinschel 1408. Now I have two other Weinschel 140608s in that group, and none of the other two checked this good. So you can't really tell by looking. You've got to measure them, and you just don't want to end up with a clunker for your VNA and not know it. So at least know the variations, and at least for most purposes, 50.2, 50.1 are good enough readings to use that particular load. The DC resistance approximates the SWR in the VNA at lower frequencies, 0 to 30 megahertz, 0 to 100 megahertz. You'll be pretty close. So it's worth your while to look around and see if you can sort out which SMA loads are the best. I have some loads that are above 26.5 gigahertz, up to 26.5 gigahertz and above. And you can see what their resistances were. I thought I'd measure those just for fun. They're all 50.0 something, but the 909 is a 26 gigahertz load. The Anritsus are 40. The 28V50 has an adapter on it. It goes to 65 gigahertz. That's a pretty nice number. And then this one, I'm not sure whether it's got a problem or whether that's an allowable variation, but I put it on a millimeter wave VNA and it checked out really well. So here's 50.017. That's a really good little load. So the bottom line is just check your VNA loads to make sure they're somewhere in the ballpark. If they're not, sort through the ones you have in trays and bins and places till you find one that you think is suitable. Okay, we'll talk a little bit about standards. The easiest standards to have in your laboratory are resistance standards. They don't change much over time. They're easy to find and people have done some good measuring on them. And here's a smattering, unfortunately, of the standards I have. The first one is a Joule primary standard. What a great piece of gear, except it takes a week to warm up. It's got a double oven in there, and it takes a week of bing, bang, bing, bang, bing, going back and forth between these two green lights until they all go out, and then it's settled down. So you want to do some serious calibration. This is the guy to have. It's a primary frequency resistance standard. Okay, let's go down the trail a little bit. Here's an IET 1 ohm standard. I can't resolve more than 3 or 4 digits at 1 ohm. And here's a Joule research that's currently on eBay. That's 1 ohm at 0.005% accuracy. The cost difference between these two guys is about $1,300. Oh yeah. So, and behind it is a Russian version of a load that goes into oil bath, and I never use it. It just was a curiosity. Here's one that's a more modern US version of an oil bath, oil immersion resistor. And there's the resistance to 7 digits. The reason I bought it is because it had a current tag on it that said what the resistance was exactly. So that makes it a good standard, and it agrees with the other loads that I have. Let's see, here's my capacity standard. Here's my wonderful 50 ohm standard. Here's another Julie Research 100 ohm standard that's very, very good. Here's a 20 meg ohm standard that it's okay. Here's an ESI SR1 CR radio 1. They come in all the decades between 1 ohm and 10 meg ohms. And if you look at one and want to get it, look at the bottom side and see if they recorded the actual resistance on the bottom. Then it's worth some money if you get the actual resistance underneath. I have several of those. Here's a little closer look with the Thomas, I think it's called, and it's a standard resistor. And the ESI, this is a 10K resistor. It says how much current you can pass through it. And it's an SR1 model at that resistance. Here's another picture of the Julie, my 20 meg ohm resistor, and my capacity standard. This is a 2.2033 microfarads. And capacity standards are really hard to get that are any good and small. Somebody on eBay had these capacitors. This company had them made. They didn't use them. He had about a dozen or two at 0.01 or 0.001% accuracy. Man, I snapped it up right away. It was 12 bucks. And at 10 kilohertz, it reads correctly and is nice to have. This 50 ohm fellow was just a random resistor I found on the tray somewhere in the lab and asked if I could take it home. It's been one of my favorite 50 ohm standards. 50 ohms is fairly hard to find, by the way. 40 ohms, okay, but 50 ohms is hard to find. Okay, there's some resistors. There's if you notice in the background, I've got a lot of test gear, and then all of a sudden I've got a K3 and a Big Holly key. Well, that's my EME station that I set up on the driveway on the other side of the garage door. Otherwise, it's all test equipment. I just put them all together. Okay, that's standards. Look or keep your eyes out on eBay for good sources, and aside from your GPS for frequency, finding a good resistance standard will help you out with your multimeters, because the reading that's most likely to change, one of the most likely readings to change fastest is your resistance reading. So this will tell you whether your meters are working right. Okay, the last thing is a Coolertron. Yay! I can't tell you how much help this was when I got it. A little 4.5 inch screen, lights, variable magnification. And here I am pointing at an LNB circuit, and here's what's on the screen. All of a sudden, my soldering got really neat, and I could see what I was doing. I stopped messing stuff up that was little. And for 120 bucks, I think that's a lot of money for something. And you can gripe about it, but if you get one, you're going to be happy, especially if you wear glasses. You look at the screen, you have your fingers down there, you have some tweezers, buy some teeny tiny tweezers and some little sharp tips, and you can solder stuff you never thought you'd be able to do before. No brainer. The Coolertrons have a 7-inch screen model with lights and so forth like this has, and maybe it's better, but the 4.5 incher like this is an older model, and it's good enough by far. It's certainly better than nothing. And it has a USB output. You can save images, play movies, whatever, the usual stuff. You can do all that stuff. Okay, that's about it. We'll maybe have a question and answer thing, but if you've got questions that don't get answered, my email is there, drzarkoff56@yahoo.com. And you can email me anytime you like with, is this any good? Should I buy this or not? That kind of stuff. And I'd appreciate hearing from you. It's a pleasure to do a talk like this, and I hope the information was useful. Thank you.